I'm going to do the notation two different ways, okay? One way if you use the inequality, and one way for the interval notation, which is the symbols with the parentheses and the brackets that I showed y'all the other day with the U's, okay? For the domain is which values? X values, right? Okay. Oh, my thing is off. So X values are left to right or up and down? Left to right. So here's what I always want you to do first before you even try and figure out where the breaks are. Think about what your left boundary is and your right boundary. And negative infinity there, positive infinity, it's going to start there, and then we're going to look and see if it breaks for X. So this is negative infinity, and this is positive because of the arrows. So now we're going to go through from left to right and see if the graph breaks. And here's what that means. It breaks if at some X point or X value, there's no point on the graph for it. So as I'm going this way, tell me when I get to, so there's X values here, right? Tell me when I get to where I have to be careful. Right here, right? What does X equal right here? Why doesn't it? I agree, it doesn't break. Why? They're overlapping. Which one means it doesn't break? The top one or the bottom one? The top one, because it's a closed circle, right? It's included. So there's actually a point right there, even though right here it seems kind of like there might not be one, but there was one here, so it doesn't break there. Okay. So now I'm going to keep going to the right. This has points. This has points. Tell me when I have to be careful again. Right here. What does X equal right here? 2. Is there a break there? No. Why not? Because there's a closed circle. There would be a break if this was what kind of circle? Open. Then that would be a break. So there's no break. And then I go to the right, and there's points. How long will there be points for? Infinity. So what happened? Where was the break for the X's? Where was the break? No break, right? So if you wrote this in inequality form, it looks like this. If you put the wikis, right, the equal bars, you're wrong. That is a partial credit. You can never equal infinity, right? You can never actually get there. So you can't include it. Here's what it looks like in interval notation. Parentheses for the infinities. Okay, that's interval notation. If you go off to school next year and if you're going to take college algebra, I'm pretty sure you'll do the interval notation. The top one is inequality. Okay, so now let's talk about the range. That is your y value. So instead of left to right, we're going to start with finding the least and the highest boundaries and then go through and see if there's any breaks, okay? So what's the least boundary? Negative, how do you know? Because of the arrow, right? So the lowest boundary is negative infinity. What's the highest y value? Is that 5 and included or excluded? Included, because it's a closed circle, right? So this is included. So now I'm going to think about where it might break. Okay, I didn't even think about that yet. I just found the lowest and the highest, and now I'm going to look in between those things. So now we're going up, right, instead of left to right. So starting here, there's points for all of these y values, right? Tell me when I have to stop and pay attention. Right here, right? At this, what does y equal right here? I don't think I did.
No, I was stuttering, sir. Like, go away.
Negative 1, negative 1, negative 1. Is that a break or not a break at y equals negative 1? Not a break, but there's 2 open circles, so it feels like a break. How come it's not a break? Because it's not. It goes off to infinity, right? So everywhere here, y equals 1. So there's points here everywhere. So that is not a break. But are there y's after it? Okay. So it breaks here, but is it included here? Yes. Because of all this solid green right here. These are not included, but these are points at y equals -1, all the way on for forever. Okay. These right here are boundaries because they're open circles, so they're not included. But these are real points, like actual points right there. So then after that, are there any points here? Here, here. All of these y values don't have any points on the graph. That is what a break looks like in the vertical direction, okay? There's nothing here. And so when does it start and when does it pick up again? At 1. And is that an included value or excluded right here? Why would you say that? That means it's included. Yeah. So if it's closed, it's included. I thought that might have been weird. So open circles mean excluded. And then there's points all the way to 5. So, yes. Because of this green stuff right here. Those are points at y equals -1. All of those are. But these, that's okay. It doesn't have to have an endpoint. It just has to have at least one point where y equals -1. Just at least one. And it does. It has all of these. These are not why it's included, right? That makes it look like it's excluded. But these are what makes it. Yeah. Yeah. Because up here, when we had the other, oh no, I don't want to say too much and confuse you. Are you okay? Are you okay with that? So then here's how to write it in inequality notation. The first interval up to the first break was -∞ to -1. And did -1 get a bar if we said it's included? The little equal bar? Yes, because it can be equal to, right? Because we're going to do because we haven't gotten up there yet. So I'm just going from here to here. There was a break here. And then I'm going to pick up now at 1, where the next interval started. And that was included. And then it goes up to 5. But you do not use a U symbol when you're doing inequalities. Using just the word or. Okay? Where's my thing? And then here's what this looks like in interval notation. -∞ to 1 with a bracket, because it's included. U, or union, and then 1 to 5. Okay. And you can always add the y as an element of here, and x as an element of here. Okay? All right. Okay, and I'm going to erase it. You have your calendar there. What are we doing in class on Friday? Quiz. You see that day on Thursday that says practice day? That has been switched. That was yesterday. So everything's moved back a day. And then we have our quiz still on Friday. When is your test?
Friday.
Next Friday, right? Guess what? Next Friday is already November. It's November 8th already next Friday.
Right?
So, all right, I'm ready to talk. Thank you. Yeah, I heard. What we're doing this unit is we're graphing linear equations and inequalities. Today we're learning 3 methods for graphing linear equations. Now I know you probably have a favorite way of doing it that's fast for you, that you can remember easily, okay? But we are required to learn these 3 methods. So if you have a problem on a quiz or test that says use a particular method, then you have to use one of the ones I'm teaching you today. But if there's a problem that says do whatever you want, then you can do whatever you want, okay? So I know you're going to be resistant to the lesson. You're going to be like, why do I have to learn all the ways when I have my favorite way? Just breathe and learn the ways, okay? There's 3 different things. As a quick review of just using a point and a slope to graph a line, because we're going to be doing that with 2 of the methods today, there's this little warm-up here that says use a slope of -2/3 to graph a line through the point 1, 1. Which thing do you remember that you do first, the point or the slope? The point, okay? So graph your point at 1, 1. And then there's two different things you can do with the slope to get your next point. Thank you. Oh, he's not here. So the slope means rise over run, right? Rise because that's your vertical direction, and run because that's this way, left to right. But when there's a negative, you can do a negative either in the top, for the top number like this, or you can do it in the bottom, which we'll talk about in a second. When it's in the top, what direction does that mean you're going to go? Down. So if it's in the top, you go down 2. And positive 3 for run means 3 to the right. So go ahead and when you do that, do you start at 0, 0, or do you start at your point? Start at your point, right? So go down 2, right 3. Now 2 points is all you need for a line. You could draw your line right here, but I want to also talk about negative slope one more time and do a third point. Because when the number is negative, the negative can go either in the top or the bottom. And here's what would happen if we had put it in the bottom instead and done 2 over negative 3. Then that would have been 2. That would have meant up 2 and left 3. And when you do that, you'll notice it's still on the same line, right? Up 2, left 3 is still here. And so then you can graph your, I'm not a very good line drawer. And I do have rulers up here if anybody feels like they need a ruler. I obviously don't feel like I need a ruler. Okay, so 3 methods today. And it all depends on what the equation looks like in the original problem. Standard form, that's not what I wanted, is when it looks like ax plus by equals c. Okay, all your x's are on one side and your constant is on the other. Slope-intercept form is when you're given it like that, y equals mx plus b. And then point-slope form starts out looking like this. We're actually going to start with number 2 instead of number 1, because it's most like the problem that we just did. The very first step is to graph a point. And when it's in this form, the point is 8, 0, 8, right? That's called your y-intercept. So the first step is to graph the y-intercept, which is 0, 8. It's whatever's in the b part. I don't remember how to get my slidey thing to the other side. It's bothering me over here. Oh well. So put 0, 8 on your graph. And then the second step is to use slope for your second point. Use slope to get second point. The slope is whatever is in the place of the m. So what is the slope here? Negative 3 over 2. So the slope is negative 3 over 2. That means to go down 3 and right 2. So down 3, right 2. And then the last step is to connect the dots. Connect the dots. La, la, la. Do y'all know Pee-wee Herman's Playhouse? Anybody? It's from when I was younger. And anyway, he would sing that all the time. So that's probably the easiest one of all of them. And it's the one you're most familiar with because you spent lots of time in algebra. If you weren't given that form, you solved for y and you put it in that form, right? You did lots of that. So on these other 2 forms, we are not going to be solving for y. We're just going to be using the form as it is given to us, okay? So we're going to do standard form first. We're going to do method 1 now. So again, these are all 3 methods to get you the same thing. And when you're given standard form, it's real easy to figure out what your x and your y intercepts are. But to lead you there for just a second, this thing is, I don't remember how to get this on the left. I'm used to it being on the left. So we're going to do the x-intercept first, but here's the thing I want to know. If you pick any point on the x-axis, like right here, what does y equal right there? On this random point on the x-axis, what does y equal? 0. What about this point on the x-axis? No, what does y equal? The y. I'm on the x-axis. 0. And if I picked a point over here, so no matter which x you pick, what does y equal? 0. So think about that. That's the math that we're going to do. So we're going to graph the y-intercept, x. And here's how we're going to do that. We're going to let x equal 0. Sorry, y equals 0. Man, I cannot. Yeah. Yes, yes, and yes. Because everywhere on the x-intercept, y equals 0. And what happens when you put 0 for y right here? What happens to that negative 4? Goes away. So just drop it, okay? And so once you just drop the y off, you're left with this, 3x equals 12. X equals 4. Okay, that is some baby math right there. You just got to divide by 3. X equals 4. So the point is the actual ordered pair. The xy point is 4 for x, and what was y? 0. And then graph that, 4, 0. That's your x-intercept.
You always do that? You don't like always drop the line?
For this one. And for the other one, you just do the same thing, but just opposite. You will get the same answer. These are 3 different ways of getting the same answer. We're just learning those 3 different methods.
Wait, why do we drop the y?
Because we plugged in 0 for it. And so when you multiply it by 0, it's just gone.
Why do you do that?
To get a point. It's an easy way and fast way of getting the x-intercept.
Okay.
Y will be negative 3, yeah. And so to find the y-intercept, so this is step 2. To graph the y-intercept, okay? And this works the same way. Shush, I was saying. We were all chill about it, and then y'all have to make noise. So the y-intercept, everywhere here, x equals 0, right? It's the same thing, same idea, just flipped. And so that's how we find the y-intercept. We go back to the original equation, and now we let x equal 0. So what will drop off here? The 3x, right, exactly. So it leaves me negative 4y equals 12. And then you do what to both sides? Divide by negative 4, so y is negative 3. So what's the point going to be, though? What is x is 0 and y is negative 3. So now you have 2 points, and you can just draw your line. And yes, if you solved for y and graphed it, you'd get the same thing. Okay, it's just another method. And what method was that one called? What did I call it? Standard form. That's if you're given the x and y on one side and a number on the other. The second method is you already have y equals mx plus b. And the third one is kind of like the second one. It just looks a little bit different, but we're still just going to pick a point and find the slope. Does anybody need that up? Can I slide back up and do the last method? We're all good? Okay. So point slope form is when you have something like this. You have y minus a number equals a number, parentheses, x plus a number. Do not distribute. This is not a distributive property problem, okay? The first thing you're going to do, and I'll explain this, but write this down for just a second. Graph the point x1, y1. And I'll explain that in just a second. So just write that for a minute. Graph the point x1, y1. I'm actually going to zoom in so you can see what I'm talking about. So right here, in this general form, here's your x1 and here's your y1, okay? Looking at the specific form, what was plugged in here to give me 2? What would have been plugged in? Because it doesn't even say minus anymore. What kind of 2 would have been plugged in? Negative, right? Because if positive 2 was plugged in, it would say minus 2 right here, right? So it had to have been a negative 2 that was plugged in. What was plugged in here for y1? 1, right? Because it still has the minus from the general form. So 1 got put in where that blue stuff was, but negative 2 had to get put in for that blue stuff. And so here's the point, that you can just pick it off of your form. x1 is this piece. We said that was negative 2. And y1 we said was 1. Right? And there's your point that you can start with. And m is 3. So we're going to use slope again. So we're going to do slope. So the second step is to use slope for your second point. And what is the slope? 3, but slope is rise over run, and 3 is just a thing. That's not over, it's over 1. You put it over 1, that's exactly right. So the slope is 3 over 1. That means up 3, right 1. And then your last step is just to connect the dots. La, la, la. So negative 2, 1. Slope is up 3 over 1. This is just me estimating. And you have your graph. Does anybody need to scroll up and see the words? Let me zoom out so it's all on there. Or zoom in, rather, or whatever I need to do. Something like that. Gotta do something.